Hello, my name is Brooke. Today we are going to have some fun with 64-bit SSE maths. There are a set of 64-bit SSE2 mnemonics in x64 CPUs that are easy enough to use and perform well. The type we will use here are referred to as scalar double, which means single value, double precision mnemonics. To make this capacity easier to use in terms of data input and output, there are a pair of functions in the MSVCRT runtime library that are used to both convert text into floating point and convert floating point to text. For simple input like a text box or command line, you can simply type in numbers and convert the text to floating point. For floating point that is converted back to text, it can be written directly to normal screen display, the console, or to a file. The first function is Ascii to floating point. This converts an Ascii number into a floating point number which is written back to a real 64-bit variable. The alternate function is floating point to Ascii. It takes two arguments, a real 8 floating point value and a buffer large enough to hold the converted results. This gives you a routine two-way conversions between text and 64-bit floating point values. The next thing to address is how floating point data is stored using an x64 CPU. The x64 Intel hardware does not support writing floating point values directly to a 64-bit SSE register. You can manually write the floating point data to an address in the data section, but it becomes tedious once you have to use more than a few numbers. To make the process far more intuitive, a macro is provided that automates the creation of floating point values so they can be used like an immediate value, which is very useful if you need to have constants in maths formulas you are writing. The macro is load_sd. Now, with the very basics explained, I will pass you over to Henry to deal with some of the examples.
Howdy. My name is Henry. The first thing we are going to do is introduce an important mnemonic. MOV_SD. The MOV_SD mnemonic is the one to use to copy data between XMM registers and memory. You have three valid forms: register to register, register to memory, and memory to register. As is consistent with x86, x64, you cannot directly move memory to memory in a single operation with MOV_SD. If you have some reason to perform that action, you must pass it through an XMM register. Now we start with a simple algorithm: how to calculate the volume of a circle. The diameter of the circle is passed as a real 8 variable as the only argument. Load the diameter into XMM0 using MOV_SD. Load the two constants using the macro load_sd. Divide the diameter by 2 to get the radius. Square the radius. Multiply XMM0 by the pi constant in XMM2. The return value is in XMM0. From the caller end, you simply use MOV_SD to transfer the return value in XMM0 to a real 8 variable.
Thank you, Henry. Just to add to the technical data so far, you can perform comparisons that set the flags, allowing you to use conditional jumps using the following. There are a pair of conversion instructions between floating point and integers so you can interact with normal integer-based code. This is by no means an exhaustive list of scalar mnemonics, and there are packed double mnemonics that can be used with 64-bit floating point values. Also note that the original x87 floating point instruction set is still available, and while it has a more complicated interface, it can perform 80-bit precision calculations and has a wider set of calculations available. A full explanation of each mnemonic can be found in the Intel instruction manuals. That's all we have for now. All the best with this primer for floating point maths. See you next time.